So with that setup, I'm either the reason you come tomorrow or the reason you won't come tomorrow. So hopefully it's the reason you come. Yeah, this is a really weird title for me because I've been at Red Hat since January. But prior to that, I was there for 14 years, from 2001 to 2013, and the first version of Enterprise Linux, bought the KVM company, created all the underlying underpinnings for containers, did the first Kubernetes deal with Google when they wanted to launch it, but they didn't want anybody to contribute to it. And we all know open source is about what? The license, but the collaboration. So I did that deal with them at the Red Hat side. I was EVP and CTO for a bunch of years there. Spent so much time down here because financial services really is a great incubation and innovator. And that just fits really well with open source. Great to see the Fidelity conversation around that as well. And then I went to Google. Some people say the dark side, but I felt like the world deserved more than one cloud. And we were number 22 at that time, which is like 40 million in revenue. First thing I did was call up Jim Zemlin and donate Kubernetes to the Linux Foundation, and it became the CNCF. So happy to be back here for another chapter. I've been at a startup for 5+ years. We're trying to bring pre-LLMs, transformers, vision to CPUs. Always with kind of that same mantra, that open's going to lead the world eventually. Often doesn't at first, right? Often it's proprietary. We're seeing this a lot in AI, but it very much so is, open source is building its roots. And what's nice is this was our vision and mission at Neural Magic, and we didn't have to change it when we came into Red Hat. So there's a big reason why we wanted to be a part of Red Hat. So here you are at MIT spin out, focused on bringing AI to CPUs, and then this thing happens. And it was pretty daunting because what it meant to us, one, is that AI quickly became a CEO mandate, right? That was part of it. So all the POCs you were doing on CPUs and smaller models, those went away. Became a CEO mandate, and it looked like it was going to be a proprietary world, proprietary APIs served, right? If all the other big frontier models followed this pathway. So existential threat, that's not just for a small company in Boston, Massachusetts, but just perhaps for the industry from an open source platform perspective. And then this thing started to happen. So that last one was November of 2022, and then it was around January, February when the first open models started to come out, and these are generative models. And I know it's kind of, we don't call them truly open source or open way, just use your favorite terminology, but what did happen here is from left to right, this is just over 2 years, the models became more permissive from license. They were very restrictive originally, so it's getting better. And they certainly got more and more capable. So where you see the open models leapfrog the proprietary models, and then guess what? Proprietary models leapfrog the open models. So it's a good place for us to be, except for there's no serving stack for these. So at Neural Magic, we're always focused on the inference side. So training has always been DIY, great open source, PyTorch, but there was really nothing on the inference serving side to build these, to run these really infrastructure demanding models that are these generative AI models. And that's what we set out. So we pivoted completely. So right now, at that point in time, you had two choices. You ran them on the NVIDIA serving stack for inference, made sense, kind of half open, half closed, had some open source licenses associated with it. I'm not sure where the line is, but it certainly wasn't like collaborative. There certainly wasn't community behind that serving stack. And then there was the Hugging Face TGI was the default inference that people were using, but then they changed the license. I don't know, Mongo-esque kind of style or whatever, but it ended up changing everything. So now all of a sudden, I heard fork a lot today already, that TGI stack started getting forked. But what happened right around the same time, this is July of 2023, so just over 2 years ago, at Berkeley, they started a project called vLLM, where the V, you can impress your friends. The V means virtualizing the GPU's memory, because that was where a lot of where the resource challenges was. So as a Series A startup, we put over $30 million into vLLM and just pivoted entirely, and that was a big reason why Red Hat bought us, because they wanted to have conviction towards the open serving stack. But in just 2 years, vLLM has filled that void for open source inference. Moreover, not only is it a really vibrant community, it was now part of the PyTorch Foundation, but it's heterogeneous. So this reminds me of my early days back in 2001 at Linux. We were coming in and sweeping up the market. They're all separate Unix stacks. We've worked really hard. We worked directly with Google, AMD, NVIDIA to get like really rich support at the hardware accelerator level into vLLM, and that just drives choice. And then now vLLM's become so relevant that it allows you to run any of these new frontier models on. So every time one of these new models has come out, it gets embargoed to us at vLLM, and then usually there's 1 to 2 weeks to actually enable it, and then you actually launch together. So when GPT-4 came out, we launched it together, Llama 4 came out, we launched it within 15 minutes, like when Zuck actually announced it. So vLLM is now, because of that, like it's that flywheel where a lot of the frontier models are serving based on vLLM, some on forks, all the hyperscalers have support for it. So it's really quickly become that de facto solution for inference. So it bodes well for those of us in this room that care about open source and building stacks around it. There was one problem that we missed as a startup. It was great. You want to pat yourself on the back, great serving stack, but then when you realized you didn't have any way to operationalize it at scale. So think about it as the early days or Linux, and then all of a sudden we had containers, but we didn't have any way to orchestrate and operationalize containers. And so it's obvious that that's Kubernetes now, but we kind of didn't know that we were missing something back then. The same thing is true around inference, except more so. Because with Kubernetes, pods and scale out, they all look like microservices. They're all pretty predictable in terms of duration. So you auto-scale them, they're quick requests. LLM serving is a completely different beast. They can be massive models, small amount of input context, large amount of input context, small amount of tokens out, large amount of tokens out, so all the workloads varying. So we did this year we created llm-d. And so what llm-d is a framework for how do you operationalize LLM serving at scale. So think, how do I build, what's your favorite term, models as a service, LLMs as a service, where there's tenants on a serving cluster or a serving data center, where you're delivering to a service level objective of that LLM. And so instead of building another serving framework, like those of us in computer science love to do, it's always fun to build something new, we decided, let's bring it to Kubernetes. So let's make LLM serving at scale a first-class Kubernetes application, if you will. So really advanced set of capabilities. A lot of what we did here with llm-d when we announced it in May at the Red Hat Summit, a lot of the advanced serving capabilities only lived in the big model servers, serving DeepSeek, serving Gemini, serving ChatGPT. They use a set of techniques to deliver models for performance and GPU offloading and efficiencies. And we pulled all those out of the darkness and put them in Apache licensed code that is now part of llm-d. And these are the really advanced capabilities. And it's not just like you say, well, you won't need them. They do a lot of GPU offloading. So it allows you to meet your SLO and have all the right dials, but then also to get like the efficiency out of your serving infrastructure. So that's what llm-d came. And then when we announced it at Google Summit, a great cast of characters contributing with it, because people quickly realize, like, if this thing's going to exist, just like Linux did, better to embrace it and advance it together. And so you see, like, Mistral's working on it actively now, CoreWeave's working actively on it now, and then as part of it, I think I heard that fork word. What we're looking at right now is like llm-d shouldn't be a Red Hat thing, it needs to be a community thing. And so we're going to take the next steps. We're already working with the Linux Foundation on where's the best home. Right, is that CNCF, is it PyTorch, is it something else? But we've already given our commitment that this will be trademark and copyright, be a community thing. So I think that's really important. And I think even though vLLM's already arrived, I think llm-d will be that future framework for how do we do inference at scale. That's it, thank you.